Hi everyone, my name is Denise and today I'm going to teach you about Java collections in our 360 class. So first, let's talk about the Java Development Kit, the JDK. You probably downloaded this a long time ago and forgotten about it. So here are the components of the JDK. The JRE right here has components for writing and compiling programs, the JVM, and next it says language and utility-based libraries. Okay, so Java collections live right in here. Okay, and I just wanted you to know that. Here's an interactive chart of Java, and you can see this in the Oracle Docs. I have a link in the presentation here, and if you go there, you can click on any one of these colorful boxes, and it'll bring up all the documentation for that. And as you can see, collections is right here in the JRE. Okay. What is an API? It's a set of functions or procedures that help you to create an application. In my Linux class, I had to create a bash script to do a binary search. Now, as fun as that was, if we spent all of our time writing basic utilities, we would never get to writing the application. So reusing code is a much more efficient way to get something done than writing something every single time. And this is why we love APIs and Java collections. So let me show you what I discovered. Here are some of the little bits of code that I've been putting together for my collections. This is an array list. And if you hover over this little box does the documentation, and this one actually takes you to the code. So let's click on the documentation first. All right, so it talks about the array list. And if you come way up to the top, there are different tabs in which you can select from, right? I'm just going to click on this package and show you this is the collections interface. And here are all of the different implementing classes, okay? Abstract collection, abstract list, abstract queue, okay? If you come to this tree thing, which I like this a lot, it gives you the hierarchy of how they are connected to one another, okay? So that's important. Now I'm going to go back to my little piece of code here, and I'm going to come and hover on this, and instead of doing the documentation, I'm going to do this. So it took me to the actual code, which is in the array list class, okay? Now, if I go all the way up here, here is the Java utility package. If I click on that, oops, wrong idea. If I click. So what this did is, I'm just going to show you right here. This is the JRE, and it opened the package. Let me scroll down here. It opened the Java util package, or it didn't open it, but it put me on it, right? And then these are abstract list, abstract map, the collections class, all of these different basically APIs that we use, and there's just so many of them, and it's kind of frightening that I can kind of get into here, because what if I mean, I don't know, is it possible that I might mess this up? But that's where it lives, and that's, you know, it's not just a mystery, and that's what I wanted to show you about that. So let's go back to here. Oops. Java Collections is a framework and an architecture for manipulating and storing data. So why do they call it a framework? I'm trying to show you that, if you can see that, okay? I'm trying to show you why it's a framework. So I watched this YouTube where there was a teacher, and he was overemphasizing about how important it was to know the structure of collections, and that it's an interview question. And so this is a nice version of what he drew. And collections is part of the iterable list, and you've got list, queue, and set are part of the collections. There are many kinds of lists and many kinds of queues, and there are many kinds of sets. So which makes sense because, oh, this is making sense because you don't, sometimes your program needs a different purpose for what you're doing. Sometimes you would need an array list, or maybe you just rather have a list that's just linked together. So the teacher bothered to go through and label all these into classes and interfaces here. So C is for class and I is for interface. And he made a big deal about knowing this. And he also went ahead and he showed extends, implements, which ones are extending and which ones are implementing. So let's take you a little bit further here. So I'm thinking to myself, well, what's up with extends and implements? Okay. This is a great review because inheritance is a big concept when it comes to Java. Let's look at the diagram over here. You've got airplane and paper, and a class called paper. And arguably both airplane and crunched up paper can fly. So they're part of the flying object class. So we say that airplane is a subclass or a child of flying object. Okay, and paper is a subclass of flying object. Flying object is a superclass of, wait a minute, I've lost my thought. Is a superclass of paper and airplane. So which would make the flying object a parent. Okay, so the cool thing about inheritances is that it features that are in common with both airplane and paper could be put in one place. So it would be put into the superclass instead of having redundant code everywhere. Notice that 2 code blocks up here for airplane, it shows the relationship of flying objects right here. And airplane extends flying objects on this definition line here. And that's like saying flying object is my parent. Okay. So you have children, parents, grandparents, great-grandparents, and in Java we have classes, superclasses, and extending superclasses, and extending more superclasses. So the bottom line is if you're extending something, it's a relationship of inheritance. They are related, and they get each other's stuff. They inherit each other's stuff, just like you would inherit your parents' house if they died. But that's how that works. So implements is a verb, and it's used with interfaces. And an interface is like an abstract class, but everything in it is just a set of instructions. So using an interface, you can say in any class you go into and type in implements and then your interface. You can implement many interfaces in one class. So all of that to say, with implements interface, you don't have to be related, and you can still be able to use the code inside it. So that's what's cool about that one. So another thing, let's talk about Adam and Eve for a second. There's a class that's at the top of Java classes, and it's kind of like the Adam and Eve of all classes. Just as everyone is born, that is related to Adam and Eve. All these classes are related to the class object. The object class can store any other class. Okay? So, all right, let's bring all these ideas and concepts together. This is the class hierarchy that I just showed you a minute ago in Eclipse in the documentation. Notice that the object is at the top of the class here. That's the Adam and Eve of all classes. See how the hierarchy is denoted here. Okay, so this abstract collection is implementing the Java util collection. What does it mean to implement something? It means, I just taught you that, it means that it doesn't have to be related. It's just a set of instructions for everyone to use, okay? So this is the abstract list right here, and list is right here. Collection was here, list is here. Collection is higher than list, and list is right here. So you can see right here that array list is under the abstract list, okay? And the array list in the structure here it has two interfaces that it's implementing, the Java language clonable and the Java util list, okay? Remember this guy was stressing that? He's like, this implements list, array list implements list, and he's right. I mean, not that he was wrong, but you know, we're understanding this now. And so you can see that Q, there's Q here, and abstract Q is right here. And set is right here. Okay, so this is why they talk about the framework or the structure of collections. Okay, so here is a nicer diagram that includes maps as well. Maps are down here, and the orange ones are interfaces, and the green ones are classes. Okay. So I will go into detail on a few of these different classes or different collections. For instance, let's start with list. Okay. So the topic of list, there's array list, vector, and linked list. Now let's go back 1 second. There are more here, but he only said we had to go over one or so, and I just thought I would compare a few of them. So array list, that's my favorite one. It gets 5 stars. So an array list can grow or shrink with data, okay, which is very different than a primitive array, because a primitive array, it is as big as you've defined it. If you defined it to hold 10 elements, that's how big it can be, and that's it. So, and it doesn't shrink either. If you take stuff out, it doesn't shrink as well. So the array list can grow or shrink, which is much better. It can contain duplicate values. The order of data is added as is into the array list, okay? It's not synchronized, which means you can use threading with it. It allows random access of data, and it's indexed. So how you're accessing it is with the index, okay? Now a vector, it can grow and shrink with data as well. It can contain duplicate values. It's ordered the same way as is to the list. It's synchronized, so you can't use threading with it. It wastes, double the amount of memory as an array list does. And it was written a long time ago, and it's much older. So, I mean, it's very similar to an array list, but I think the array list is better because it doesn't waste as much memory, because even though it does grow and shrink, it actually allocates 50% more in chunks. So there's that. Then the linked list is an implementation of or implements DQ. So this, if you look at this picture down here about linked lists, okay, it starts out, the first one has a memory reference. The linked list works basically in a chain, and they're all linked together, and each node or each box here holds the data plus the next memory reference, okay? So it's a chain, and it has memory references, and instead of indexes, it makes it much faster when you're inserting data a lot, because all you have to do is change the previous and next references. You don't have to re-index from that point like you would have to in an array list if you were doing that. So searching is slower because you have to start from the beginning and go through it. And it's not thread safe. You have to lock this yourself if you're going to do it. The ending node is known to be the ending node because it has a null at the very end, okay? So sets, a hash set, all sets can't handle having duplicates, okay? So you can't have just none of them can have duplicates. It's just part of being a set. The hash set has no guarantee the data will come out in the same order. So if you're accessing it, several different, each time that you access it, it can come out in a different order, printing it out or whatever. So there's no guarantee there. It is the most light of any other sets. It's not synchronized, and it's not, and I found that it said that it's not thread safe. So the linked hash set, though, on the other hand, the order is maintained here every time you access it. But it's not necessarily stored that way. It just has something that helps it. Let me just read the next thing and you'll know how that's happening. The performance between the hash set and the tree set, the performance is between the hash set and the tree set. Like, it's not as fast as hash set, and it's not as slow as tree set. So the linked, it needs to maintain a linked list inside of it in order for it to come up with the same order every single time. And so that's how that's happening. The tree set, once again, no sets like duplicates. So the elements are sorted, which more overhead is needed to, as far as performance, because it has to sort the elements after every insertion and removal of the operation. But the retrieval times are faster because it is sorted. So it's not synchronized and it's not thread safe. The queue, all right, let's look at this picture over here. Let's just imagine getting gas. Sue is at the head, so she's first, then Joe, Bobby, and Sally, and there's the tail. And to get in line, it's in queue and in queue. And to get out of line, you're being DQ'd. So Sue in this situation was DQ'd to the gas. So priority queue is a set of code in the collections that you can use. It holds, usually queues hold the same type of elements. The priority queue is sorted, but it's not stored as sorted. It's not thread safe. So if you wanted a thread safe one, you would use priority blocking queue. No nulls are allowed in any of these queues. Okay. Blocking queue is basically, it blocks when the line is at capacity, and it also blocks when it's empty. And the queue, the regular queue is thread safe, and it's not sorted. It's first in, first out. And once again, no nulls in queues. Down here, I have a little chart. I found that there are certain methods that will throw an exception on insertion or removal or peeking or examining, whatever, and others that won't. So this chart was kind of good to say, even if you do an offer, it's not going to throw an exception. So hopefully I'm reading this right. It won't throw an exception as the add would in some situations. This made sense to me before. I'll revisit that. All right, so maps. We're at the very last one, maps. We've got hash map. There are more maps than those, but all of them contain unique elements only. And the hash map maintains no order for data coming in. It stores on the basis of key and value. It won't give you an exception if you ask for the key and it doesn't have it. So it just gives you nulls. That's why there's a few reasons why I like this hash map. So this guy gets my 5 stars as far as maps go. It's not synchronized, so it gives you faster performance. If you remove a record and key doesn't shift up for the remaining elements. So say you had a list of 1 through 10 and you took the number 6 out, 1 out, it isn't going to shift 7 through 10 to be in order again. It's not. The 7 will remain 7, the 8 will remain 8, and so on. So the hash map is unsorted. The hash map, someone said that this would be a good for using the headers in the REST API session ID. Okay, I'm not sure exactly what that is, but I guess this is used a lot in doing that. And so I just thought I'd put a note in there for us for later. It may have only one null key and many null values. So you can have null values quite a few times, but only one null key. In the tree map, I'm actually going to go down to this hash table. Unique elements only stores on the basis of hash code of the key and then value. Okay, it's synchronized, no null key values, or you'll get a null pointer exception. You can't have a null key and you can't have a null value, or you'll get an exception. I've seen that. So tree map contains only unique elements, again, stored on key value, and it stores data in key order. So that's kind of good. If you needed your data stored in order, that would work for you. So, well, I think we've went through it. I'm going to actually go ahead and make other videos of the actual code so that this isn't so long. I hope that this helps you understand collections better. Thank you so much.